in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
Alright, what's up everybody? This is working. Get my webcam to work today. Brio doesn't want to work today. Girl, why are you giving me issues? Pfft, 1 sec. It's always something, dude, I swear. Let's try that now.
Yo.
What's up, dude? 1 sec. I'm trying to get this to work.
You just started?
Nice. There we go. That started. Let me get we're good on that. We're good on that. Twitch has started. My PC is being very sad. So we're now streaming to 3 different things. We're doing YouTube, Twitch, and TikTok. Oh, see, why is it not getting the what's up? What's up, Lazo? Frozen Fusion. Happy Monday, dude. Nice, there you go. 1 sec. This needs to
Creating sensation.
1 sec. Activate source. Why is this not reading correctly? Girl?
Teacup.
See, I see my Twitch here, but I don't see it here. Why is that? 1 sec. That's annoying. We're gonna do, there's a couple of test things I'm doing today, so give me like 5 minutes. I need to, because this is the first time I'm trying this live. Let me see. We'll give you some like music, some like hip hop music while we wait. Bum bum bum. That should find. Yes, activate. Good. Okay, that one's working. YouTube looks good. Then I don't know why it's not finding. Why it's not finding Twitch. 1 second, let me go through. Talk. Yeah. No face cam. Yep. You had no school today. That's awesome. Nice, dude. Dope. All right. Let's see if that comes through. No. Oh, okay. Can someone talk on the Twitch? Someone say something in the Twitch. Just type the chat in the. Joffrey says cats. What's up, cats? Yo. Okay. Nice. Okay, that's working. Thank you. Okay, we know that's working now. Okay, good. All right. I don't know. Maybe it takes like a minute or two for it to actually work. And then, all right, let's see if we can get TikTok to work today. Where's my lo-fi music? I need my music, dude. There we go. Let's see. Okay. We're trying a lot of things. All right, let's go live here. It kind of looks different than before. What do you mean it looks different? How different does it look? Oh, the chat's gonna look different. Yeah, the chat looks different. Yeah. So we're using a new like integrated chat thing. So I can now do chat across all the platforms, hopefully. This.
Oh yeah, the chat is on like dark mode or whatever.
Yeah, exactly. Yeah. Let's see. Let's go to YouTube. Just want to make sure this runs.
That looks much better, to be honest.
You like it?
Yeah,
Nice.
because it was too bright before.
Yeah. So you should see that, and I think if someone finds us on the send one. Okay, wait one second. What is this saying? It's getting mad at me. And one to the backup URL. Oh. Interesting. One sec. I need one to go to the backup URL. All right, let's copy that. Let's switch this. YouTube Shorts output. One sec. The vertical. Output settings. Good. Oh, send this one to the backup. Cool. All right, let's try it again. What's up, Shanktrix? Good to see you, dude. Okay, I think we're live here. Let me see. Testing that comments work. Let's see if it pulls it in through here. Doesn't seem to be pulling TikTok. Why is that? Okay. That's the vertical canvas. This I want to go to the primary. That's okay. Cool. That I want to go to the vertical. That's cool. Okay. Now I want to see if YouTube comments work. One second. No. Yo, what's up, Do the Math? Good to see you. Doing our little live stream tutoring thing today. Okay, let me see if that works. Yeah. Okay, cool. Comments are working there. All right. I need comments to work on. Oh wait, there we go. Oh, I need to log in. Why do I need to log in for this? Excuse me. Can I just like? One sec. Wants me to log in with a QR code. TikTok has all this weird security with them. All right, let me scan this code. Scanny scan. Cool. Good. Confirm. Authorize. Nice. All right. Thanks, Do the Math. Appreciate that. Okay, so now let's see if this works. Let's see if this works. Testing. Okay, now they do work. Wow. Okay, now my question is whether YouTube is playing just the vertical or also playing the horizontal. So I think the last way to test that is to probably pull up YouTube Shorts on my phone. Yeah. So you should see there on the chat. You see how there's a YouTube and a TikTok? You can have them run through all of them. It's part of my plan for global domination to just spread learning everywhere.
That's dope.
Okay, let's see. Let's see if this works. So if we go to me, it does say I'm live. I think it says I'm live. One sec. Oh, YouTube? Me? Yeah. Okay. It says, but I don't see us live on the vertical though. That's my only issue. I see it on the horizontal. Is there a separate app for YouTube Shorts? I think there might actually be one, right? Yes, Shorts. There we go. Shorts. Cool. Where's like Shorts Live, maybe? Einstein of Twitch. Yeah, I did this this was my project over the weekend. I was seeing if I could get this to work. Interesting. All right, I don't think our vertical encoder is working. Yeah, let me turn both of these off real quick. It's gonna get mad at me. It's okay. Ba-na-na-na-na. Yeah. No data. Okay, that's fine. All right, now I want you to stream though. Vertical canvas. There we go. Okay. Nice. Oh, it says we're live. That's cool. It's getting that. Interesting. I wonder if that's to shorts though. Let me see. Wait, let me check it on here. Dun, 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 dun. No. Let me see. New UI looks better. Yeah, thanks, dude. Yeah, I worked like hours this weekend trying to get this to work, and I'm testing it today. Because I see the home, but I don't see that we're live. Wait, it says we're live. Okay. Ooh. Okay. Cool. Yes. Okay. So now I see. See, we're vertical now. This is cool. This is really dope. I'm glad this works. Okay, now I want to see if I can get the horizontal to work as well. Ooh, YouTube's gonna get mad at me. It's gonna be like, "What are you doing?" Thank you, brother. I can draw at Lewis. Nice, dude. I'm glad. Very glad you can draw. Okay. I think people create different channels, is what they do. Whatever. I do help with calc too. Yes, I really do. Yeah. Here, I'm just gonna stop the horizontal because I don't think anyone actually watches our horizontal streams, anyways. Okay, cool. All right. Thanks for being patient. Everything. Yes. So, for those that have found us on the variety of different platforms we're streaming right now, this is called Office Hours. My name's Dr. Gold. This is Actual Education. We're the stream that helps you out with anything math, science related, middle school, high school, even up to early college. If you want to get help with your question, the easiest way to do that is to use the URL down below there. It says actualdiscord.com/submit. So if you use that URL, you can submit a screenshot of what homework question you want us to go through live on the stream here. And if we pick it, we'll do it. I'll try to do as many as I can today. I only have an hour and 40 minutes because I got to go teach another student multivariable calculus today. Yeah, that's going to suck. Okay, and let me okay, that's streaming. Good. Oh, Teacup's in here too. Great. Okay, awesome. All right, cool. Let's start off the show. Welcome to Office Hours. My name's Dr. Gold. It's Actual Education, streaming helps with math and science homework, all that fun stuff. Yes, thank you for being patient for the first 13 minutes here. Well, I can only test this stuff live is the problem. I wish there was some way to upload to a dummy server and then just see if it runs, but they won't let me do that. The web link isn't in the Twitch. That's okay. That's actually a good point. Well, it actually is. Do you see right down there on the scrolly thing? On the ticker, it's there. It's down there on the ticker. I guess most of the people on Twitch have Discord, so I encourage them to sign up on Discord. Whereas I understand people that are finding us through TikTok and whatnot probably don't see us right away there. And here, let me make sure this works. Testing shorts chat. Let's see if that works. Yes, cool. That works too. Nice. All right. Sweet. Except that looks messy as fuck down there. Wow, ill. I think I need to turn off the Twitch. Do we want to be street chat separator chat? Not stage chat. Where is it? Oh, I see. Yeah, I know what I gotta turn off. One sec. I gotta turn this one off. There we go. All right, because we had Streamlabs on as well. Okay. A lot of questions today. That's good. First up is Marcos. Marcos, are you in the chat? This was his. Let's see if his is here. Post this in. Marcos had a physics question he wanted to go over. This is a fun one. This involves two separate. Sensation's not here tonight. Okay, that's fine. And that's not the one I want. That's the one I want. There we go. Let me turn this volume down a little bit. Okay, cool. Okay, one sec. Let me ping Marcos, if Marcos is here. Otherwise, here, let me help out Teacup, because you have a test tomorrow, right? You need help, Teacup? And you haven't asked for help in a while, so I feel like I should give you a little bit of preference up front. Is that cool?
Hello.
What's up, Teacup? Good to see you, dude. All right. Here we go. Graphing, is that what you have to do? Graphing, evaluating, simplifying, condensing, expanding. You can choose which ones you think are the most difficult. Okay. Probably this one. Probably condensing. Condensing logarithms kind of suck. Okay.
Logarithms themselves suck.
I like logarithms. You don't like logarithms?
Oh, it's my teacher. Teacher sucks.
I know that happens, unfortunately.
It's the same teacher I had last year too.
Oh yeah, she's just absolutely terrible. Okay, cool. Can you see everything here? Right? Yeah. Can you see the? Nice. Okay. Cool. All right. It says condensing logarithmic expressions. Okay. First thing I always like to do whenever I have these is I want to get any numbers that are in front of the logs like away. Oh yeah, good. Josh, more practice for you. Yeah, good. So I don't like the 1/2. I don't like the 3 here. What do I do to get rid of those?
You put them in the exponents.
Good, exactly. Yes. So you can put this up in the exponent. So this is the same thing as log base 6 of 25 to the 1/2 plus log base 6 of 2 to the 3rd, right?
Yeah.
Okay. Next thing I like, you can evaluate this, right? What's 25 to the 1/2? What's up, Mondo?
Oh god, 25 to the 1/2. Isn't that 12.5?
No. So to the 1/2 always means to the square root.
Oh, so it's 5.
Yeah, so it's 5. Yeah, nice. This is the square root of 25, which is just 5, yeah. Mono says the only logs I like go in my wood-burning stove. W, dude. There's always the pickup line, right? Of like, hey girl, do you want to go get some dinner and see if I can integrate my natural log or something? Terrible fucking joke.
Surprise, motherfucker.
Anyways, okay.
What the hell?
2 to the 3rd we know is 8, right?
Yeah.
All right, good. I'm glad we know that. Awesome. Okay. All right. Now you have 2 logs which are being added to each other. What's the rule for adding logs?
They multiply.
Yes. They multiply. So this is the same thing as the log base 6 of 5 times 8. So now that's just the log base 6 of 40. Nice. Right? And that's all you have to do. Yeah? Did those steps like make sense, Teacup?
Yeah.
Okay, nice, good. All right, let's get first question. Let's do this one. All right, go away, Olaf. Okay. What about this? This is fun. This is like reverse. I think they want you to expand these. This is like condensed, and they want you to expand them. Okay, cool. Yeah. So, I like to think like big picture, what's going on.
Well, since it's division, we turn down to 2 subtractions.
Good, exactly. Yeah, right, yeah. I like to think that, okay, look, I have something here divided by something here. And so I know I can write that as the log of, this minus the log of this.
Yes.
Yeah? Okay, cool. So you just take away the boxes. Jeffrey says, is it okay to tell a student that logs are a shortcut way to multiply using addition and to divide using subtraction? I don't know if I would call that a shortcut way. Logarithms are really used to pull things out of exponents. So
logarithms are used to find exponents.
They really are, yeah. So for instance, you have like 5 to the x is equal to like 25. x is in the exponent, right? And you can't like divide by 5. It doesn't really work. The only way to do this is to pull it out by taking the log of both sides. It is kind of a different way, I guess. Yeah, I wouldn't say it's a shortcut. But yeah, you do use them a lot for algebraic manipulating of things if you want things to be subtracted instead of divided. Yeah. So yeah, this is going to be log base 3 of 9y to the 4th minus the log base 3 of x to the 8th. Okay, this is cool. What do you think you can do next?
Oh god. I'm at a loss.
Well, let's just attack this one first, right? So right off the bat, so some kids would be tempted. They would be tempted to take this 4 right here, and they would want to pull it like right out front. That's wrong. Can't do that. No. Because this exponent to the 4th only hits the y. It's not hitting the 9 as well. Okay? So you actually have to split this one first into 2 different logs. That's the better way to do this. How do we think we do that?
Well, they're multiplying together, technically.
Mm-hmm.
Oh,
So you could say log base 3 of 9, and then it's plus, right? Log base 3 of y to the 4th. Okay, then let's keep this thing over here. Yeah, split the log into 2. We're like literally like chopping it down. We're just like chop.
so then it's log 3 of 9, which I'm pretty sure is just log. That's just 2.
Yeah, so this is just 2. The reason why this is you should always be kind of on the lookout to see if this number can be written as a power of this number. So whatever's inside your log, if it can be written as the base to a power, that's going to help you out. So in this case, you have the log base 3 of 3 squared, right? 3 squared is the same thing as 9.
Yeah.
And so when that happens, you actually get to pull the 2 out front. And now you just have the log base 3 of 3. But what's the log base 3 of 3?
Log base 3 of 3 is 1.
It's just 1, yeah. Exactly, yeah. This is just 1.
So it's just 2 log of 1.
Yeah, it's just 2 log. It's 2 of 1. Log base 3 of 3 is 1, not log of 1. The log of 1, that's equal to 0. Yeah, you don't want that. This is 1. This whole thing here is 1. So then this is just 2 times 1. Yeah. The reason for that is that, let's remember, so if I have the log base 3 of 3 is equal to, let's say, some value x, you can rewrite this in exponential form as this to the this power equals this. So this is the same thing as 3 to the x is equal to 3. And like 3 to the what equals 3? Just 3 to the 1, right? 3 to the 1 is the same thing as 3. So
yeah.
That's why if you have the log base of the same number, that's just always equal to 1. Okay? Next thing here, we can pull the 4 out, right? So that's going to be plus 4 log base 3 of y. And then here, you can pull the 8 down, so then that's minus 8 log base 3 of x. And then I believe this is the simplest form for it. It's the most expanded. It's actually the messiest form of it.
No,
right?
I don't like
This is the simplest form. We like this. But this is the messiest form of this. Yeah.
Go back to the other one.
Right up here.
No, it's fine.
Oh, do you want screenshots of all this?
Huh?
Do you want screenshots of these things?
Yes, please.
Okay, here, one sec. Here, I'll download this one for you.
I want to fail these tests.
You're not gonna fail the test, dude. I mean, it would be helpful, you know, if we were helping you out not the day before your test. I'd say, like, come get help, like, sooner. So I can, you know, we can help you out. Okay, cool. There's that. What else we got? Change of base. Yeah, this is okay here. Let's do this real quick.
We like it messy.
We like it messy. I don't like my apartment messy. My apartment's a fucking bombshell right now. I need to go fix that. But yeah, I was spending like 4 hours this weekend trying to figure out how to do multi-stream with OBS. That's what I did instead of cleaning my apartment. Oopsies.
Fire.
Fire. Okay, evaluate the given log values or using a change of base. Okay. Well, that's pretty cool. How do you think we do that?
Well, you changed it. Oh god. So if log 8 of G is 0.5 trillion long, yeah, I got no idea.
Okay. Well, change the base, right, means changing this thing right here. Changing the 8. Yeah. Okay. So what you can always do, if you ever want to write like log base A of B, this is the same thing as log of a new base B over log of a new base A. This always works out. Okay. So that's one way to do things. So I think that's what they, because now you're changing it from log base A to this new log base X. But what you do is you do the log of the top thing divided by the log of the bottom thing, the base thing. Yeah. So they say log base 8 of 3 is that, and log base 8 of that. Oh, they want log base 8 of 54. Oh. Okay. This is actually kind of cool, right? I think it's cool, man. We want to write 54. We're actually not even really change. Oh, or it says or using change of base. Oh, okay. I don't think we need to use change of base. I think we can just do this regularly. We just want to write 54 in terms of 3s and 6s. Okay. How can you write 54 in terms of 3s and 6s?
54 and 3 and 6. Oh god.
Yeah.
Off the top of my head, I got no idea.
Okay. What are some factors of 54? Like, how could I write it like factored out?
$54 factored.
Yeah, like
Well,
right
it's
now has a bunch of factors.
154. Oh god. 3 and 18. 6
Okay,
and
3.
9.
I like 3. Okay, look, 3 times 18. Cool. I agree with that. How can I break down the 18 then?
18, 9 and 2.
1 second. Let me see. 1 second. Where's my GPU? Yeah, you can break it down into 9 and 2. The other thing you could do is 3 and 6, right?
6, yes.
Yeah, right. Yeah. See how that might
can
make.
be 3 and 2.
Yeah, but that might make things a little bit better, right? Yeah. So this is the same thing as 3 times 3 times 6. Yeah. So what I'm gonna do here is I'm gonna say, okay, log base 8 of 54 is the same thing as the log base 8 of 3 squared times 6.
Okay.
You see that?
Yes.
Okay. Now, I can do logarithm rules on this, right? I can break this up into log base 8 of 3 squared plus the log base 8 of 6, yeah?
Yeah.
And then I can bring the 2 out front. So now this is 2 log base 8 of 3 plus 6, or just plus log base 8 of 6. But those were the numbers they gave to us, right? See how they gave us log base 8 of 3 was this? So this is 2 times 0.528. And then this one is just 0.862.
Oh.
Yeah, that's what they wanted you to do. They just want you to rewrite this thing in terms of these logarithms, which means you need to write the 54 in terms of 3s and 6s. Yeah? Okay. Cool. So yeah, so that's what that is. And I guess you could do some math on this, right? So this is the same thing as, where's my calculator? Pull a calculator up. Oh, I need to make sure chat doesn't come above the calculator.
There will never be new things in the vault.
There will be new things in the vault. I need to, don't worry, I'll get on it. I'll get on it. 1 second, put the calculator down. Okay, cool. So that's 2 times 0.528 plus 0.862. So yeah, there you get your answer, which is 1.918. Teacup stole everything. Yes. Okay, cool. Does that make sense?
No, Ethan stole everything.
Where is Ethan these days? It's his birthday today, actually. Happy birthday, Ethan, by the way. If you're watching, I know it's your birthday. I think it's also Noyce's birthday, wherever Noyce is. Right? Is it Noyce's birthday? Yeah, I think it is. One second. Let me make sure this audio is working here. Okay, that one is working. Nice. I'll check the TikTok in a second. What is... Oh, this is easy. You should know how to do this. Oh, and then here, let me save this as a picture for you real quick. Okay, there's another one. Okay. When you raise something to the log of the same base of the number, this, yeah? Do you know how to do this?
Nope.
Okay. If this number is the same as this number, this goes away. And you're just left with this. So the answer here is literally just X. Yeah.
Wow.
It would be the same thing if your teacher did this. E to the ln of 5. This is also just equal to 5. Because ln...
What does ln mean?
ln just means log base E. That's all ln means. ln just means log base E.
Oh.
Yeah.
Okay.
So it's not that hard.
log 10.
Sorry. Log of 10, sorry, what?
Nothing, sorry. That's my bad.
No, you're good. You know, E is like 2.7 something, I think, technically, is what it is. Right?
1.718.
2.71, yeah. I want to see, one sec. Need ways to check things. Okay, cool. Right, that's an easy rule. And then I think this is probably the last one, which is graphing. Yeah? How to graph things?
Yeah, it's my like biggest weakness.
Okay. The easiest way to graph things, I find, is to do this. Like, just come up with points, dog. And try
to do.
Okay, cool. Now, what you want to do is you want to try to make this part of the function equal to some power of this. Because if we have, for instance, log of 2 base 2, you know this is just equal to 1, right?
Yeah.
Okay, so what's a value of x I could put in to, like, make this nice?
2.
Well, no, if I put... Well, yeah, I'll get to why that one works as well, but I would want to put this as 3. Like, x is equal to 3. Because then 3 minus 1 is 2, and log base 2 of 2 is just 1.
Yeah.
And then it's 1 plus 3, which is 4. Okay, this is a good value.
And
We like this.
minus 1 is 1, which means it's just 0.
Good. And then 0 plus 3 is just 3, right? So this one works as well.
Yeah.
Okay. And then you should always try to find out what's like the asymptote. Oh, thanks for the follow, dude. We should try to find out what like the asymptote here is, which is always just when this is equal to 0. Because you can't take the logarithm of 0 or below. Logarithms only work for positive numbers. Good. So yeah, so 1 is like doesn't work. So what I would do is right here at 1, I would draw like a big kind of like vertical asymptote.
Yeah.
Okay. All right. And then you have your points, right? Look, right? 2, 3. So you like 2, 1, 2, 3. Yeah. 3, 4. So 1, 2, 3, 1, 2, 3, 4. Right? So now you know your graph looks something like this. Okay? Because it's always going to approach the asymptote, but not actually hit it.
Yeah.
Cool. Yeah. And that's all you really have to do. I mean, you could find some other points here. I mean, another thing would maybe to say x is equal to 5, right? Because then 5 minus 1 is 4. 4 is 2 squared. Log base 2 of 2 squared is just 2. 2 plus 3 is 5. Yeah. So, I don't know. 1, 2, yeah, whatever. Yeah? Cool?
Yep.
1, 2, 3. Okay, nice. Good. Okay, does that make more sense to you? Yeah?
Good.
Sick.
I'm gonna pass.
Yeah, you're going to do well on your test. I know you will. What's up, Lucas?
Alright, have a good one, Gold.
You too, man. Appreciate it.
The month return will be next month.
What? What about next month? Oh, why is my sound not
I'm
working?
good, man.
One sec. We gotta fix our sound here. Settings.
What's up?
Yo, is this Alex? Sorry, I haven't
Yeah.
checked my thing. It is.
Yeah.
Oh, nice. Good to see you, dude.
That's dope.
One-
I didn't wanna. I didn't play in the Fortnite tournament because I was with my friends.
Oh, it's okay, dude. You know, you come in next time.
Yeah.
Where's-
Also, what time is this live then? Because I'm about to go and eat.
This is going until probably. I want to say for another hour and 15 minutes. Yeah, Shantrick says, "Yo, what's up, dude?" He sees you. Yeah.
Yeah, I have a new question.
Oh,
I'm
good.
a- Up it up.
Do you have a new joke of the day for us as well, dude? You have a new joke of the day?
Yeah. Yeah.
Okay. What
I'll
is it?
get-
What is it? Yeah, go get us a joke of the day, dude. We want to hear it.
Yeah. Let me get my computer because I don't really remember it.
Okay. He's gonna go get us first, real quick. Okay, cool. I think this is working. Test. Yeah. Okay. Y'all tell me on TikTok if you can hear me, or if you can hear me clearly, or if it needs to be louder. I think I may need to boost the levels on this. It's hard for me to test everything. Yes, I do high school question. Yeah, high school physics for sure. Yeah, I teach AP Physics a lot. So yeah, please, yeah, feel free. There's you can submit questions using this. Or is it submit? There you go. It's slightly louder. Joe, do you want it louder? Should I make it louder? I can make it louder. One second. Let me do that. Thank you for like. I have so many mixers on this thing is the issue. One sec. Device properties, levels. Let's boost this girl up. All right, there we go. All right, is that better? Yeah. Appreciate you, Joe. I'm streaming right now on Twitch, YouTube, TikTok, and Discord. So, luckily I have a dual PC set up to do this. So, TikTok is handling. So this streaming PC is handling TikTok because they require their own app, whereas Twitch and YouTube and Discord, yeah, you can run everything through OBS, which is nice. TikTok is they like keeping things in their sandbox, so they don't let you use a stream key, which is annoying. Okay, what's up, Alex?
What's up? I'm loading up my computer, but I
Nice.
have good news. So I took like my state PM, like a statewide test.
Okay,
then-
how'd it go?
I got the highest out of my class.
Wow, that's dope, dude. Nice.
I'm loading up my computer.
Okay, good. All right, here, Adar, so let me help you out with your question because you were here. He says, find the numerical value of the log expression. Log of A is equal to -6, log of B is equal to -6, log of C is equal to -1, and then you give, they give you this mess. Man, this is
You gotta get in
ugly.
the hospital now.
This is gonna be painful.
And I just said, just shut up and let me enjoy this pain.
I am gonna enjoy this
You gotta
pain.
get in
dude.
the hospital
I'm gonna
now.
really, very much enjoy this pain. Okay. So this kind of goes back to what's up, Alex?
How did the Fortnite tournament go?
It went well. Yeah, we had a good time. I think the winner was I want to say Equity and Cuber. They got a victory royale and they got 28 eliminations. So yeah, that's another thing we do on the streams on the weekends. We play Fortnite and host like tournaments. So that was fun. Yeah, come by for the next one. We'll do it next weekend. Okay, Adarsh. Yeah, this question is like really sad. Yeah, it is. It's I don't know. If I was Rick, dude, I'd be crying at this one. Yeah. Oh no, Coral. Okay, the way to break this up is to kind of think about this in big chunks. That's what I like to do. So what I would do is divide this into like, okay, cool. I have this big honker down here and this big thing up here, and they're dividing each other. So I know this is the same thing, right? As the log of the blue thing minus the log of the red thing. Exactly. Right, yeah. So just do that. Yeah. So when we do that, that's c to the 4th. And then I always like to write these roots as exponents. So this is a to the 5th, b to the 5th, all to the 1/3. Because the cubed root is the same as raising it to the 1/3 power. Okay? Now this is easy, because I can just pull the exponent down. So this is just 4 log of c, which we already know what log of c is, right? So this is just, well, we'll do the stuff at the end. Here, I can pull the 1/3 out if I want. Okay, so this is minus 1/3. If log of a equals log of b, doesn't that mean a equals b? It does. Yeah, does it not? I'm pretty sure it does. A to the 5th, b to the 5th. Okay, great. And then here, I need to expand these out, okay? Now, the key thing here is this 1/3 technically is going to hit both. It's the same way that the 1/3 hit both things in the parentheses here. So this is going to be minus 1/3 log of a to the 5th plus a negative 1/3 log of b to the 5th. This is the tricky part. This minus sign, this minus 1/3, needs to show up in both places. Okay? Sometimes students will they'll multiply this through and then do it, but this minus sign is tricky. So watch out for it.
You want to see the joke of the day?
Yeah, let me finish this question, Alex, and then yeah, we'll have you on and you can show us the joke of the day and what you're going over in class. Cool? Let me do this real quick.
Yeah.
Okay, cool. And then this is minus 5/3 log of b. Okay, cool. Now we're Gucci. So I know log of c is -1. So this is 4 times -1. That's -4. Log of a is -6 times -5/3. So this is plus 30/3. And then this is also -6. But why do they make the same thing? That's like lame. Okay, this is also plus 30/3. 30 over 3 is just 10. So you have -4 plus 10 plus 10. So that's going to get you a final answer of 16, I think.
Well done! Well done!
Nice. Okay, let me give points to people. One sec. Add one. I forgot to give a point to Teacup. I got to give one to Adarsh. Darsh. There you go. Nice. Okay. Cool. Yeah, you're welcome, dude. Nice. Okay, Alex, what's up? You got the joke of the day?
Yeah.
All right, let's see the joke of the day. Let's see the joke of the day. So he's gonna show it to us. Okay, here's the quote. Oh, Bill Nye. I love Bill Nye. Bill Nye's dope. Everyone you will ever meet knows something you don't. Ooh, I like that. Yeah. Wait. You have a meme? Your teacher puts a meme on the thing for the day as well?
Yeah.
What does it say? Monday, here we go again? Oh, Tuesday, we meet again. Tuesday, we meet again.
My teacher did a, what's it called? He put the wrong day.
Okay. Yeah, because it said it's January 1st. January 21st. It's definitely not January 21st. Okay. Joke of the day. They say most dogs bark up to 350 times a day. Okay. Oh, okay. Oh, yeah, that's just a rough estimate? That's funny, dude. I like that. Nice. That's a good one, Alex.
What's it called? I'm gonna send the question and then I'm gonna send it. What's the? I don't know. I know where to send it. It's like what's it called?
You can send it in the help screenshots channel, or
yeah.
You can also if you want to just go to a website, you can upload it from your phone that way. If you don't want to deal with Discord, but also help screenshots works. Yeah.
Okay, that's what I'm gonna do.
Okay. Let's see. Nice. Shantrix has a question here. Okay. Let's see here. Okay. Y is equal to the absolute value of x. Y is equal to 2x minus 3 plus 9. Explain how you can use vertical shift and horizontal shift to determine the coordinates of the second equation from the first equation. Oh, okay. I think they're missing a squared here. Or... Wait. Is there supposed to be a bar here, Shantrix? Is this supposed to be like barred? Not parentheses? Yeah, all good. Okay. How I always like to work with these is I look at what's closest to hitting the X, and then I move outwards. And yeah, it's important because the order to which you do things matters. So, for instance, if I move something up a certain amount of units and then I flip it over, or let's say we have something here, and let's say we go like +3 up to here, and then I flip it over the horizontal axis. This would be the same thing as doing this would be X. Oh, this would okay here. This would be Y is equal to X plus 3, and then like putting a negative on it, right? That's different than flipping this over the x-axis first and then raising it by 3.
Yeah. What does it flip over? It's usually the most important question to answer. Yeah. Thanks for the baby voice, Ricky. This would be written as y is equal to negative x plus 3. These are two different things. Notice how here, right? You added 3 first and then you flipped, which will get you a different final point, versus raising 3 and then flipping, which will get you the point down here. And you can actually see how these are different, because this looks the same thing as y is equal to
negative x minus 3. Yeah. So order matters when you're doing transformations. You want to be careful with those. You can also, in theory, do it in any order if you also move the axis of reflection. Oh, very good point there, Obi. Yeah, you're right. That's a little bit more high level than most kids are probably used to. But yes. Yeah, if you move the origin point, that does work. You're right. What's up, Reki? Okay. So, this looks like this. Y is equal to 2, and then its absolute value of x minus 3, and then it's plus 9. Yeah? Okay. Looking at the first thing that's happening, right? This is going to be a horizontal shift to the right of 3. So anytime something is very close to the x, that usually deals with horizontal things. So for instance, if there was like a 2 here, this is a horizontal stretch or compression. And then horizontal things, I like to say, are backwards to what we think they would be. So in this case, minus we would think moves it to the left, but that's wrong. Minus, because it's horizontal, actually moves it to the right. It's also kind of the same thing with the stretches. If you put a number that's greater than 1 here, that does not stretch it this way. It actually compresses it horizontally. Versus this, for instance, will stretch. And if this is a fraction, right, this would expand it horizontally. Whereas if this was a fraction out here, this would compress it vertically. Yeah, 2 things you gotta kind of like keep a lookout for. Okay, so I would say horizontal shift to the right of 3, and then this part here would be a vertical stretch by a factor of 2. Beautiful morning, going to school. Nice. Is that Laz? Is that Laz that's saying things? No, it's Skeeg. Okay, Skeeg. Okay, cool. Nice. Because you need extra 3 to get from... Yes, exactly. Why does it goes positive 3 to the right? Yeah. Okay, I'll explain that. That's actually a good question. And then here, let me just do the last thing here, which is then it does a vertical shift of 9. Of 9 up. That's the last part that this does. And this is the order that it does things. Okay. Yeah, that's a good question. Like, why is it backwards? Okay. So if, for instance, you had a graph, let's say you had y was equal to x squared plus 3. Okay? We know that would look something like this. Okay? So this right here would be 0, 3. And then this would be, for instance, I'm not going to do this to scale, 1, 4, and then this would be like 2, 7. Okay? Now, if I have a new graph that is, for instance, y is equal to x minus 2 squared plus 3, okay? Now what happens is that in order to get this to effectively be 0 squared plus 3, I have to go even higher in x. I need x to equal 2 for y to equal to 3, or like to hit the vertex. So this whole thing here now gets shifted to, I want to make sure I do this right. Yeah, it gets shifted here. So now it ends up looking something like this. And that's why minusing shifts it to the right. You can kind of think of this as like a handicap. It keeps like knocking the x back. Such that if I put 2 in here, it's the same thing as putting 0 in here. So that's why x has to equal 2 here to get to the vertex. Whereas here, it could just equal 0. What's up, Alex? Yeah. Whereas, okay, this, for instance, right? This boosts the y value directly. It doesn't really care about the x, right? This boosts this from being just a lonely y is equal to x squared, which would just be this. Okay. That 3 there boosts this up by 3. Whereas doing any modification, this is like modifying the input of the function, takes away 2 already, such that you have to go over an additional 2 just to like get your graph started. That's how I like to think about it. You tell me if that kind of makes sense. Like it's kind of a better way. Nice. Ooh, Vivi submitted a screenshot. Nice. Is that the spherical shell? I love this question, by the way, Vivi. Okay. All right, cool. Nice. Good job there, Shantrix. Yeah, the constant, yeah, the vertical shift on the right, yeah, that's a constant.
Well done! Well done!
Okay, nice. Let me help out Vivi. Vivi just submitted a question. This is a physics question. This is a good one. Okay. I forget where Vivi found us. Somewhere, right? Where did we find you? Oh, Gauss's law will be my downfall. You have a unit test tomorrow. That's okay. All right. The solid plastic sphere. Oh, it's a sphere. Okay. Okay. I love how they label it this way. Like, excuse me, this is hilarious. Insulating, conducting. Okay, great. But like, it's already said here. Okay. Or you wrote these things, maybe. Okay. I'm not gonna shit talk anymore. That's my labeling. Okay, great. I'm glad you're labeling things. I'm glad you're highlighting the important aspects of this question. Okay, consider a Gaussian sphere concentric with the plastic sphere. Okay, so concentric means it starts in the center here as well. Okay. Derive an expression for the charge enclosed by the Gaussian sphere. Okay, this is a good one. All right. Gauss's law, right, says that E dot dA integral, right, is equal to Q enclosed over epsilon naught. Is that the equation you all learn? Do you all use this one? I think you do. Yeah, okay. Now, for a Gaussian surface, this E dot dA term, the E is constant. So the whole reason why we learn, like, I know, Gaussian surface sounds like kind of like a weird thing. It's that, say, for instance, you have a charge Q here. This creates an electric field, right, that points out in all directions, okay? And the magnitude of this electric field, right, we know from KQ over R squared, right? The magnitude of that electric field drops as the radius gets bigger. But notice it's as the radius gets bigger, I don't care where along the radius it is. That's why if you were to look at some constant distance r, the electric field everywhere here would be the same, right? Because r is the same, all right? You can now extend that into 3 dimensions where we're looking at a sphere, okay, of radius r. Now, everywhere on the surface of this sphere, the electric field is the same. So, when you do this E dot dA with the integral, you should remember, I don't know if you've taken calculus yet, Vivi, but if you're doing the integral of like constants, let's say the integral of 5x squared dx, you can always pull the 5 out because this thing does not depend on x. And the same thing here, if the electric field is constant because you've picked a clever shape such that everywhere on the surface of this shape the electric field is the same, then you can pull the E out, and now it's just the integral of dA. And the integral of dA is just A. It's the same reason like the integral of dx is just x. So that's why you get E dot A. And A here is the surface area. dA is like, they call it like the surface area unit. This is also kind of like more like vector calculus, but E dot A is equal to Q enclosed over epsilon naught.
Mr. Gold.
What's up, dude? Dr. Gold. You have to say Dr. Gold. He'll get it eventually. It's okay. What's up, dog?
Is it okay if you save my question until I get back?
Yeah, I'm good. I'll be here for another hour. So just hit me up when you come back, okay?
I have 15 minutes to eat.
All right, yeah,
20.
go eat some food. Yeah, don't starve.
See you.
See ya. Okay. The area, this A here, is dependent on the shape you chose. And in this case, the shape we chose was a sphere because everything here looks like a sphere. You're almost always going to choose your Gaussian shape to be something that mirrors the thing you're looking at. So if you're looking at a line charge, that creates electric field out this way, which ends up looking like a cylinder. So that's why you use a cylinder. And if you have like a flat thing of charge, you end up using... Do they still use the word pillbox with you guys? I don't think anyone fucking knows what a pillbox is. But you use a box for like a sheet of charge because the electric field is constant everywhere, like this. Okay. All right. So E equals 4 pi r squared. So let's just get to the nitty gritty of things. So what you end up getting is that E is equal to 1 over 4 pi r squared, and then it's Q enclosed over epsilon naught. Oh, and they want an expression for the charge enclosed. Oh, okay, and then we're gonna do for the magnitude of the electric field. Oh, this is cool. They break it up into 2 parts for you. Usually they would just ask this, and you'd be implied to figure this out as like an in-between step. Okay, let's just do this. This is easy. Okay. E&M, yes, we love E&M. What's up, Fembox? I'm actually teaching E&M at UCLA over the summer. It's going to be an online summer school class. I'm kind of terrified by it. What's up, Mouse? Or Mosul? Mousel? Okay. Evil online help. I know. Right? Okay, so let's look at the charge. So, a spherical conducting shell. Okay, this is conducting. Wait. Okay, cool. Okay. The shell has an unknown charge. The solid sphere has a uniform density. Does it have the same charge, Q? Oh, see, they give you a row here. Oh, inside. Okay, here we go. You know, it's okay. So this has a charge of 2Q. Is that what you want to tell me? Yeah, you're good. And they still don't tell me what the charge on the conducting shell is? I guess you don't need it. Okay, that's fine. All right. So, if R is less than A, right? We know there's a uniform amount of charge here that is 2Q. So, if R is equal to A, let's say we're here, then I'm enclosing the whole sphere. And so my charge would just be 2Q. if my r was equal to 0, right? If I wasn't like enclosing any of the inside of the sphere, then it would be 0. Can we use Green's function? That's a little bit overkill. I mean, this is kind of like some sort of Green's function thing. Okay, but this is how this works. So charge is proportional to the volume enclosed. Okay? This is what they mean when they say it has a charge density of rho. So look, charge density is equal to rho. Let's remember what rho is, right? Or what density is. Density is usually like mass over volume, right? In traditional physics, like mechanics, we usually say density is mass over volume. When we get to E&M and we start talking about charge densities and stuff, this is equal to charge over volume, okay? And we say that this is constant. You can think about it as like the density of an object, right? If something's like completely lead, then it's the same density everywhere, which means the amount of mass you start looking at goes up as you start looking at more volume of it. Here, rho is constant, equal to charge over volume. So that tells me that the charge is equal to rho times the volume. Okay? So as you enclose more volume, you're going to enclose more charge. So if you have half of the volume of the inner sphere enclosed, then you're going to get half of the charge. And the way to write this is that, so Q enclosed is equal to Q total, and then it's times volume enclosed divided by volume total. Do you see, Vivi, how like this is like the percentage of the volume that's being enclosed? It's like volume enclosed divided by volume total, and then this is the total charge. So this is the total charge is 2Q. Why does the mass affect the amount of charge? It doesn't. No. I'm just making a parallel between these two things. Yeah, this is not actually in the question. Okay, so Q total is equal to the volume enclosed, so Q enclosed is equal to Q total times volume enclosed, which that's gonna be 4/3 pi r cubed, divided by the total volume, which is 4/3 pi, and the total volume of this sphere is a radius of a, so it's 4/3 pi a cubed. Okay, so then these things are going to go away, right? And you're just left with it's equal to 2Q r cubed over a cubed. Okay, that is the charge enclosed here. Exactly, mass and gravity, exactly, yes, yeah. This is why a lot of people like to say that E&M and gravity, like, connect. Yeah. Physics, better. Math is pure. Anus. Thanks, Notorious Trader, for that. Okay. Okay, now we say for R is between A and B. Okay, so when we're here between A and B, the total amount of charge enclosed, like let's say for instance we are, let's say we're this one. Let's say here's like where we're enclosing charge. We're still always just enclosing 2Q. So it doesn't matter where we are, right? If I'm like out here or in here or in here, we're always enclosing 2Q. So then this is always going to be 2Q. Okay? Yeah, I agree, Notorious, that math can seem a little weird because you don't see the real world applications of what you're using, but just trust. You'll get to it eventually. I don't know what math you're in so far, but I felt the same way during pre-calc, because pre-calc seems to be a bunch of random fucking topics. You're like, oh, we're learning about sine, now we're learning about logarithms, now we're learning about this, and you're like, what's the point of all this? It's only when you get to calculus and you start doing things that require knowledge of those like prerequisites that you start getting the point of like, I see. Yeah. Calculus makes it... I love calculus. Calculus is like the hero's journey, and then you understand, oh, this is why I learned all this bullshit. Trig is fun? Yeah, Trig's cool. Okay. Oh, show work. You don't need to show work. You can just say that, like, for instance, you don't enclose any more charge between A and B. Oh, you have an exam on relative motion? Cool. Yeah, if you have a homework question or like a practice test question you want to go over, just submit it to the website down there, and we'll get them. Okay. Yeah, you can just say this. You can just say you're not enclosing any more charge. You could also say that between A and B is a vacuum, right? This is vacuum. There's nothing here. So there's no charge. What eventually gets tricky with the conducting spherical shell is that there is charge, but it's only on the outside. So what happens is, let's say, for instance, this was positively charged. You're going to end up getting negative charge just on this side, and then you're going to get positive charge just on this side. So as you move through the conducting shell, you don't enclose any more charge. But once you get outside, then you are enclosing all this. Yeah. It's cool. Okay, so then for this one, for getting the magnitude of the electric field, right? That's just using this equation. And now Q enclosed is just what you're plugging in from part A, okay? So here, let me put this on a new page because there's like too much shit going on. Okay. So let's remember this equation, right? So for part A, and for section 1, right, for R is less than A, we said that Q enclosed was equal to 2Q R cubed over A cubed, all right? So then for here, you're gonna do the same thing. 1 over 4 pi R squared, Q enclosed is now 2Q R cubed over A cubed, okay? And then there's still an epsilon naught down here. These R's are gonna cancel. So this is gonna go away, you just get R. And then you have 1 over 4 pi epsilon naught. And then there's like, what, this is like 2Q over A cubed. This right here, this 1 over 4 pi epsilon naught, this is the same thing as K. So this is the shorthand for where this comes from. So this is why it's going to be K, and then it's 2Q over A cubed. Oh, and then there's still an R here. My bad. There's still an R. I forgot the R. Oopsies. Still an R. Yeah. Oh, did TikTok end? Oh, that's lame. One sec. Let me figure out what that is. One sec. You know what it is? Because it gets mad at the timing. Yeah, it's after an hour. It says that we haven't done anything. One sec. Let me fix that. I gotta fix that. Let's fix that again.
What's up?
What's up, dude? I don't know why it does that. Okay, there we go. All right, it'll go back again. One sec. I do need to fix that with TikTok. How far advanced are you in physics? I'm decently advanced. I have a PhD in physics. Does that help? Although my PhD is in plasma physics. Yeah, get an auto clicker. Yeah, I probably will have to do that. Yeah. I wonder if TikTok can detect that, though. Okay. Yes, so that's that. Okay, now here's the cool thing. That's for part 1. Right, Vivi? For part 2, let's remember that the Q enclosed is just always going to be 2Q. Okay? So now when you do your equation, this is just going to be 1 over 4 pi. I'm going to move the epsilon naught over. Epsilon naught. And then this is just 2Q over R squared. So this is the same thing as K 2Q over R squared. And this should kind of make sense, right? Do you see how this equation comes back from classic E&M, right? It's just KQ over R squared. And that's just for the electric field. You know what's funny, Shantrix? Yeah, even though things say they're random, like random number generators, they're not. They're never actually truly random. Bots can still tell that they're not. It's an interesting aspect of it. Okay. Pseudo-random. Yeah, they try to be random. Yeah, they can tell. Even computer-generated random is still not random. That's why sometimes if you do stuff to like set like your crypto wallet or something, they make you click in random places because humans are actually random. If a human like decides on places to click, like the movement and whatnot, that's considered more random than a computer trying to generate random things. It's pretty cool. Okay, Vivi, does that help you out? Yeah? Make a little bit of sense for you? Is anything really random though? I mean, depends what you really think about, you know? Yeah. See? Okay, good. Nice. Good job. Good job.
Well done! Well done!
Nice. Okay, cool. All right, that was a good question. Alex, here, you want to go over yours, Alex? You submitted something, yeah?
Yeah, I did.
Okay, perfect. Love this. Let's do it. And then Nick, I'll work with you, yeah? I think you're next.
Yep.
Europe. When's your test? Isn't your test coming up soon?
In under
Dog.
2 weeks.
Under 2 weeks. Uh-oh.
Surprise, motherfucker.
Yeah.
Okay, one sec. I'm uploading Alex's very high resolution photo. This looks like IXL. Are you working with IXL?
Yes, I don't like it.
I know. So actually, I'm curious. Why do you not like IXL? You want to tell us why you don't like IXL?
Well, for this, because I used to do what's it called, Math Nation. It was better
Okay.
because it actually teaches you what is wrong. This one just tells you, it just gives you like the right answer.
I see. So you don't get feedback on
Yeah.
why you got something right or why you got something wrong. Ah, interesting. Okay. I guess that's why having a tutor or asking questions here on a stream comes in handy, because if you're getting things wrong, we can explain why they're wrong, right? Okay. Cool. All right. Oh, and then I am gonna have to, one sec. I have to fix this. I'll do it in another tab. One second. Let me do another tab. One sec. I'm gonna edit the data here.
It sometimes gives us feedback, but the feedback, I don't really understand it.
I see.
Like, but in Math Nation, it gives you like a video about it.
But it's not like super helpful. Okay. That totally makes sense. All right, here we go. Let's do this one. Let's pull us in. DiffyQ, yeah, real world applications. Cosmic says, I don't like my math professor at all. Why not? What's wrong with your math professor? Uh-oh. Okay. Riley is training to complete in a marathon following a training plan recommended by her favorite running podcast. Wow. You know most people get their information from influencers now instead of the news? Or podcasts? Okay. She plans to run 12 miles in her first week. That's a lot. Excuse me? And will increase her mileage by 10% every week after. Write an exponential equation of this form that can model Riley's target mileage per week, y, x number of weeks after she starts training. Cool. I like this. Okay. All right. So we have this, right? Y is equal to a b to the x, and x is equal to the number of weeks after training.
Yeah.
After starting training. Okay.
Yeah.
All right, here's how I like to do things. Okay, let's say, for instance, that she has just started. Like she's just started her training. What would X be?
Yeah.
She's literally just started.
12 miles.
Well, what would X be? Remember, X is the number of weeks, right?
Yeah.
So if she had just started, what would X be equal to?
0 weeks. 0.
0. Yes, exactly. Right. Cool. So X equals 0. All right. So let's like try plugging that in. Yeah. So here I have Y is equal to A and then B to the 0. Do you know what B to the 0 is?
1.
Good. Yeah. Anything to the 0 power is 1. So this is gonna go away. Okay. And then how much did we say she trained at the beginning? Like how many miles did she train?
12 miles.
Good. So which one of these things? What letter here is gonna be 12?
A.
Good. Yes. Actually, they're both gonna be 12, right? So Y is the number of miles she trained. So 12 is equal to A times 1. That means A must equal to 12. Good. All right. Cool. So we got the first thing. We got 12, right? So now I can replace this with 12. Okay. All right. The next thing we need to do is we need to determine B. Okay. There's another name for this. What do they call this in like exponential land?
I don't know.
They call it the common ratio. That's what they call it.
Oh, I never. My teacher never said that to me.
Yeah. No. It's so that has to do with like how much something is going up or down. All right. So here's how the equation for that works. Okay. B is always equal to, and it's going to be 1 plus, and it's going to be it's going to be some sort of rate. Okay. And then this is the rate increase.
So wouldn't the rate be 10%?
Good. So what would we write R as in terms of a decimal?
0.10 or 0.010?
0.1 is what I would say. I said 0.1.
Yeah, 0.1.
Good. Exactly. Okay. And then what is 1 plus 0.1?
1.1.
I love that famish. That's hilarious. 1.1. Okay, good. So this is Y is equal to 12. And then this is 1.1 to the X. Yeah. This is your final answer, by the way. This is all you have to do.
Oh, that's easy.
It is. Okay, but let me make it a little bit trickier. What if she was decreasing her mileage by 20% each week? What would that change?
If she was decreasing by 20%, it would change the B value.
It would change the B value. Good. What would the new B value be if it was decreasing by 20%?
0.2.
So close. Yeah. So you're right. You're gonna change this thing here to 0.2.
Yeah.
Okay. But then it's gonna be 1 minus 0.2. Okay. Not 1 plus 0.2. If it was 1 plus 0.2, this means increasing. This means decreasing.
Yeah.
So what would 1 minus 0.2 be?
0.8.
0.8. Exactly. Okay. And what that represents, 0.8. Do you know what is 0.8 as like a percentage?
8%.
80%.
80.
Yeah, good. You always take the decimal here and you move it to the right twice. And then you have to fill in the zeros. That's why it's 80%. Yeah.
I was like confused between 8 and 80.
Yeah. What's up? Is that Rubug? Did Rubug find us? What's up, Rubug? Yes. Good. Yeah. So if it's a 20% decrease, it means it's 80% of what its original value is every time. Yeah. Cool.
Yeah.
All right. Nice. Does that make more sense to you? Yeah.
Thank you.
Yeah. You're very welcome, dude. Nice. Good job.
Yeah. I'm gonna just stay around in this stream, okay?
Yeah. Stick around. We're gonna be chilling for the next 30 minutes. I got 30 more minutes to teach. All right. Let's see. If Riley actually ran 10% more each week, how much would she be running 52 weeks from now? It's actually a good question. Yeah, if you wanted to know that, right? You would just plug in 52 into here, right? And so, if we pull that into a calculator, right? Where's my calculator? There it is. So 12 times 1.1, all to the 52. So damn, she would be running 1,700 miles. Oh my god, that would suck. Famish says, you'll stream when there's no more help needed. Yeah, unfortunately, I have to help a student out with multivariable calculus after this, so. I know. I would like to just chill on TikTok the whole day. TikTok, Twitch, and YouTube. Can't even do that. Yeah, 168-hour week. Yeah, that's a lot of miles, man, right? That's a lot. Okay. Let's see. Nick. What's up, Nick? Nick, you around? Yeah?
Yeah.
Okay. Wow. What the hell? Dude, what are these questions, bro? What?
I don't know.
Oh my god, dude, what?
I just send you random things because I didn't know what the hell it is.
Yeah, this is probably outside
This
this is where like you have to actually like probably get a track person to teach you how to do these things.
Like, how are you supposed to know that?
Yeah. Rue says hi to you, by the way, Nick. She's on the YouTube. She's on YouTube Shorts.
Ari?
Yeah, Ari.
Pee pee poo poo.
Beep beep boop, boop, he says. Refer to the plumbing sketch. Is this the plumbing sketch, by the way? Is this the plumbing sketch?
Yeah. The second picture that's with this one is the answers to this picture.
Okay. Well, let's try to understand this. Dude, what the hell?
And then there's another one the same with both together.
Okay. The vent stack 3 should be made of. Okay, so they're talking about this.
What the fuck is that?
I don't know how you're supposed to actually know that, bro. What they say? What did you put the right answers here at least?
Yeah.
Cast iron? I mean, I don't know. How the hell are you supposed to use that? I don't know.
Little dots, bro.
Yeah, what is this? This is really scary. So this is the Trackman worker exam. Which is, yeah, this book. Yeah, Nick's applying for a job as a Trackman worker, but he has to, like, these are the questions for the test. He has to take a test in it, which is a little bit tricky. But yeah. Yeah, what is that? Exactly. What is that? Okay. I don't know exactly how you're supposed to learn these because I don't know what valves are for a meter. This stuff, I feel like you just have to memorize. Yeah. Like the plumb
or
fitting.
guess.
Well, I mean, because like, bro, like, is this a toilet? Like, what is this? What is this thing? Yeah. Well, okay, WC water closet. This is a toilet. We literally found a toilet. I think we
This looks like very funny.
Yeah.
It looks very funny.
Yeah. Yeah, exactly. This is like English versus science. Yeah. There's not really tutoring for this question. It's okay. Yeah, those you need to just memorize. This one here. This one is math.
There's another picture of it.
Yeah, I see. Yeah, this one I can do math for. This is okay. This right here is just like, yeah. Yeah, I don't know what that is. Yeah. I'm not gonna get that anytime soon. Dun, 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 dun. All right, let's see. Let's do these. Okay, these are okay. These are questions that are doable. Okay. The distance from 1 to 4. Okay. Do they want like the Pythagorean distance?
No, just regular.
But wait, where's 1?
Yeah, that's 1 and number 2.
Is 1?
Oh, 1 to 4. I mean.
Is 1 in the corner here and it is 4 down here?
Yeah.
Oh, I think you do have to use Pythagorean stuff here, dog.
No. Look on the bottom. Look on the bottom of the square itself.
Yeah, I see this. Okay.
Yeah, you just have to add 1 to 2, 2 to 3, 3 to 4.
But like, why would they give me the vertical distances?
Because that's for number 33. To find the X in the middle.
Okay, 1 sec. Well, all right, maybe let's see. Is this the correct answer? We know this one's 4'9".
Yeah.
Okay, let's make sure that that works out. Okay, so they're saying the distance from 1 to 4. So that's from here to here. Okay.
Mm-hmm.
Yes. You have to add some things. So you have to add. Here, you have 1 foot, 3 inches. Then you have another 7 inches. So you have 0 feet, 7 inches. And then you have 2 feet, 11 inches. Okay. And this is where I'm going to add things down this way. So this is 3 inches plus 7 inches, which is 10 inches. 10 inches plus 11 inches is 21 inches. And then this is 3 feet. Okay. But now, right? 21 inches is way too much, right? How can I write 21 inches?
Yeah. 4 feet.
No, just the 21.
Inches?
How can you write just the 21 inches? How could I write 21 inches in terms of feet?
12.
Okay, subtract 12, right? Yeah. So this is the same thing as another foot, and then how many inches left over?
3?
9, because it's 12.
Yeah.
Right? 12 plus 9 is 11.
3 more. Yeah. Okay.
Good. So then these combine, and you get 4 foot, 9 inches. Okay, cool. Yes, which is answer C. Yeah. Dun-dun-dun. Johnny, you should go see a doctor, dog. The distance from 2 to 6. Oh, wow. This is kind of ugly. So we're going from here all the way to here?
Yeah.
Okay. So 2 to 6. Okay. I should do these on different pages, actually. Just because it's going to be hard to see them all. How much time do I have left? Jarhi asks. I have 26 minutes. 26 minutes. 26 minutes. Okay. 2 to 6. Okay, so that's going to be 7 inches. Then 2 feet, 11 inches. Then 1 foot, 6 inches. And then 1 foot, 7 inches. And that's it, right? Yeah. Here to here. To here. To here. Okay.
Who thought of the idea of putting him like that?
Well, that's just the American system, dude. I know, it's just like...
No, no, someone from, got their name.
Just freedom.
The server.
18, 24... Sorry, what do you mean? What are you talking about?
Someone thought of this idea to put it like that, from top to bottom. It helped a lot.
Oh, yeah, I think it was Seth. I think Seth came up with it.
Yeah, Seth.
I think it's Seth, dude.
It was really
Freedom
helpful.
units. Okay, 4 foot, 31 inches, right? How do I break up this 31 inches?
Subtract 24.
Okay. Ooh, Melly has a screenshot. What's up, Melly? Thanks, Melly. Okay. So, this is... Yeah, 24 inches, so that gives you 7 inches. And then, what does that add here for the feet, then?
2.
2. Good. So then this becomes 6 foot, 7 inches. Which, yeah, is the right answer. Okay. I'm just going to help you out with X here, and then I'm going to move on to the next question, because whatever. You can do the rest yourself.
Yeah.
The distance X
this one is hard.
between the lines of the holes. Oh, okay, this isn't... Well, wait, no, this is actually kind of fucked.
Yeah.
Oh, no. You have to notice that they give you the distance here. They're giving it in a bunch of different places.
But I tried. I don't know why I can't get the answer correct.
It's okay. All right, look. So from here to here, you have some distance, right? And then that goes over to then say between here and here is X, right? And then that goes over to say between here and here is something else. Okay? And then the whole thing here is 9 inches. Right? This whole thing is 9 inches. Okay? So you can say 9 is equal to 2.5 inches. Dude, I hate the mixed fractions, dude. Plus X inches. Plus 3.25 inches. Yeah, very American. Oh, wow. Jarhi says that physics question we worked on together was actually an extra credit was an extra credit question on the test. Nice. Yeah, that's the advantage. I mean, your teacher, if they're fair, will a lot of times reward people who do the homework by making those questions appear on the exam again. So, yeah, it's kind of a little incentive. I say it's a great hack, you know, and that's why I tell all you guys to submit screenshots to me, because that's the best way for me to help you. Is if we work through a question that your teacher gave to you, 9 times out of 10, something like that is going to show up. What's up, Alex?
I have to go.
Oh, okay. Good to see you, man, dude. Have a wonderful, you know, rest of your... Was today Monday? Yeah, today's Monday, yeah. Have a wonderful rest of your Monday, dog.
See you.
We'll see you, dude. Okay, if I add these, 2.5 is the same thing as like 2 2/4. So this ends up being 5 3/4 inches. Plus x is equal to 9, yeah? Oh, thanks for the follow, dog. Okay. How do we get to x?
Sorry, what happened?
So this plus this got me to 5 3/4, and then plus x gets me to 9, right?
Mm-hmm.
So how do I figure out what x is?
Subtract 9 from 5 3/4.
Well, I would subtract 5 3/4 from 9. That's the way I would do it.
Oh.
So yeah, I would say okay, cool. So 9 minus 5 3/4 is equal to x. So if it was just 9 minus 5, that would be 4 inches. But then we're subtracting 3/4 of an inch, so that's gonna end up being 3 1/4 inches.
Mm-hmm.
Yeah, and I think that's the correct answer, right? Yeah. This should be 3 1/4, not 31 quarters.
Yeah.
Yeah. Anyways, yeah. Thanks, Malzo. Yeah, dude.
Damn.
Yeah. Have a good night, dude. Appreciate it. Okay. Awesome. Yeah. Good job.
Thank you. I swear I did that. I don't know why I got it wrong all the time.
All right. Let's see. We got a couple questions. Disable. Happy Face and okay. So Happy Face has a question. Let me pull this one in. The bouncing spring. Yeah, this one's kind of annoying. And then I think someone else, Melly, not this one. Sorry, get rid of this.
Can you send it to me, please?
Yes, I will. It might happen later today. I'm a
Okay.
little pressured for time. What's up, Melly? Yeah, Melly. Let me do yours because you submitted yours. Okay, here we go. Oh, is this light years? Oh God. This looks like relativity. I'm about to get tested on my... I fucking hate relativity. I need to get better at it though, honestly, because yeah, it's a basic physics thing that I should know. Okay. Which question do you want to work on, Melly? Is it the... Oh, it's these ones, right? Oh, this ones? I can see them. Yeah, I can see them. I assume these are the questions, yeah? Work on 3. Where's 3? 1 sec. This one, the answer here, the laws of physics hold true in any inertial reference frame, thus the time wouldn't appear. Okay. Okay. Maybe it's from here. Well, wait, sorry, what is this? These are thought process answers. Where are the thought problem questions? Are these the questions? I see 3 here. But I assume this is the answer to a question. I just need the question. How advanced may a homework be for you to check? Oh, thank you, Melly. There we go. All right, Melly sent in one more thing. Cool. Let's pull it in. I'm going to try to read it. You can try me, dude. Yeah, you can try to send me whatever. I'll tell you real quick whether I can do it or not. Alright, it's uploading. Give me a second. Oh, it's a big image. Big image. Maybe I should have opened it in... Okay, here we go. There we go. Okay, question 3. Okay. Oh, here we go. Anthony and Bill are stuck on a train that is traveling at 90% of the speed of light. The boys measure out the distance between them to be exactly 20.12 meters. Bill throws a ball straight at Anthony. The ball is measured to take 1.2 seconds to reach Anthony. Julia, on a field that is 20.12 meters long as the speeding train. Okay. On a field long as the speeding train passes, she measures the length of the distance between them and how long it takes for the ball to leave Bill's hand to arrive at Anthony's. Yeah, if you ever want to know, yeah, use exclamation point Cal. Yeah, Mosul, that's the calendar you can figure out when we're streaming. Okay. This is an interesting question. Let me try to pull this one sec. No, go over. Running out of mouse space. Will you just minimize all my stuff, Google? One sec. There we go. So I'm gonna make this smaller. Alright. One sec. And then let me pull this in. Yeah, it's a tricky one. What length with Anthony and Bill? Oh, okay. Wait, one sec. Wait, number questions, and then I guess A, B, and C are the practice questions, or the like the thought questions or something. 3A. Oh, sorry, I'm being really dumb. This has ABC part of it. Okay. I was looking here and I was like, where's the question? This is part of the question. Okay. Would Julia's distance measurement of the two boys on the train be longer or shorter than 20.12 meters? Okay, cool. Yeah, this has to do with length, time dilation and length contraction, right? So when something else is moving at the speed of light, which it's all relative, right? Okay, so if you, for instance, see some distance here that's measured, let's say, to be like 20 meters, but you are moving very close to the speed of light, you're going to see that as a shorter distance. That's called length contraction. In the same viewpoint, if someone was sitting here and they saw you, let's say you have like, I don't know, a stick that's like 5 meters long, they are going to observe it as being shorter as well, because you are moving towards them is effective as you are moving towards them. Moving towards you is the same thing as you moving towards them, also close to the speed of light. Yeah. Okay. So I believe what the equation for this is right, is x is equal to gamma x naught. Is this what we say? Where gamma, I want to say gamma is, one sec, I need to figure out, I remember what this is. Special relativity gamma. Yes. It's like 1 over v minus squared. Here we go. So is Julie experiencing a proper time? Okay. Yeah. One sec. Let me get this first. I just want to make sure we get the right value here. She's did it 90% of the speed of light. Okay. So v over c is equal to 0.9. So this is the same thing as 1 over the square root of 1 minus 0.81. Okay. Okay, and then this is gonna be this over gamma. So that's 1 over 1 minus 0.1. So that's the square root of 0.19. Let's see what that is. Where's my calculator? Okay. And then we're going to do 20.1. So this ends up being 2.29. and then you take this distance that she measured, right, the 20.12 meters, and you divide it by 2.29. And that gets you the 8.77, which is correct. Okay. All right, but let me explain this, not just with. I mean, it's fun to do equations and numbers and stuff, but let's kind of. I want to take your question about the proper time here. 1 second. Give me a second. Yeah, explain, please. Yeah, okay. Let me just look this up. I have to remember what the definition of proper time is. Okay, proper time is defined as the time interval measured in the rest frame of an object, okay, in the reference frame in which the object is instantaneously at rest. It is invariant and mean that different observers and different will agree on the value of the proper time, along as even if their individual clock readings or okay. Yeah, this is where you could draw a Minkowski diagram if you really wanted to, but I don't want to for this. Okay. Yes. So, Melly, your question is Julia experiencing a proper time? Correct. Yes. Because there's this invariance here that says if two observers are in a relative motion, they're going to disagree on measurements of length, time intervals, and things happening at the same time, simultaneity, right? This is why there's length contraction. But they always agree on each object's proper time along its own path. Okay. So proper time is within their own frame. So you could think of the proper time of the people on the train. They're going to measure a time. And then Julia on the field is also going to measure her own proper time. But that time is the same in their own reference frames. Okay. Okay, here we go. Let me try to go through this explanation. This is why I do love ChatGPT for trying to explain this, because my knowledge is vast, but there's a lot of things that I have to remember. Okay. Okay, so proper time is a time measured by an observer that sees both events occur at the same spatial location in its own frame. It is the time measured by whatever is actually making the trip between the two events. For the ball throwing scenario, the events are ball leaves Bill's hand and ball arrives in Anthony's hands. Since Julia, sees those events occur at two different places, she's not measuring the proper time for that journey. Okay. But if the ball had a clock on it, then that time from it leaving Bill's hand and arriving in Anthony's hand, that would be the proper time. Okay. Okay, this is the key thing here, Melly, is that two events have to happen in the same spatial location. Because she's chilling here, and the ball being thrown, from Bill to Anthony, is whenever these two events happen, the spatial location of what she's looking at is different, right? Because the train is moving. So she's experiencing proper time, but she does not measure the proper time for the ball. Okay? I believe on the frame of the train, these people do measure the correct proper time. Although maybe they don't, because the spatial location of the ball changes. Right? Right. Yeah, it's cool how it explains it as like the events, right? There's the event of the ball leaving Bill's hand and the ball arriving in Anthony's hand. But because this thing is moving at the speed of light, now the spatial location isn't like constant. So yeah, the proper time isn't there as well. But I don't think you have to go that in depth for this question. I think, well, here we go. Would Julia measure the time it takes the ball to reach Anthony's hand to be longer or shorter? This is time dilation, right? This is why she measures a longer time. Again, it's the same gamma, but for distances, you divide by gamma to get length contraction. And then for times, you would multiply by gamma to get time dilation. Okay? So, yeah, and that's what we figured out, right? It was like 2.29. So 2.29 times 1.2 probably does get you close to the 2.7. And then what length would Anthony and Bill measure Julia's field to be? So Anthony and Bill are going to measure her field to be shorter, because again, in their frame, it looks like the field is moving towards them at the speed of light. Is this the same as what Julia would measure the length of their distance apart to be? I think so. Yeah, because the field is 20.12 meters, and the distance between them is also 20.12 meters. Oh. Yeah, the gamma stuff is pretty crazy, yeah. Okay. Does that help you out a little bit, Melly? In general, again, I don't know at what level. Relativity, don't worry. This stuff is confusing, and it is honestly a mindfuck. Like, it'll mess with you a lot. So don't feel bad if it's confusing, but try to keep things straight where distances contract, times dilate. And it's always, as long as things are moving towards each other at the speed of light. And that can be an object moving towards you or you moving towards the object. It's all about, like, who's looking at it from whose point of view. Yeah. Okay, cool. Glad. All right, I got 5 more minutes. Let me help out Happy Face. I think I can help you out, Happy Face. Let's do it. Jarhi. Where's Jarhi's question? Okay, here we go. All right. A weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reaches 0.3 seconds, the weight first reaches the meter. Okay, let's just say this is at, I need a smaller thing. This is t is equal to 0.3. Okay. The next low point, 40 centimeters, is at 1.8. And then this is the low. This is the max, right? Okay, cool. Sketch a graph of the sinusoidal function. Oh, cool. As it bounces, you start a stopwatch when the stopwatch reaches point. Okay. It is a sine wave. Well, yeah, I think it's a sine wave because it reaches the max at some non-zero time, right? Unless there's a phase shift, but I really don't want to do that. Okay, let's assume the height is equal to, so we got to look at what the amplitude is, right? So amplitude, right, is always high plus low divided by 2. Is that right? Is that how it works? No, it's high minus low divided by 2. Yeah. Okay, so, and it's the absolute value of this, right? So that's going to be 0.75. Okay, so height is equal to 0.75. Sine, I think this is 2 pi over the period times the time, and then plus some initial height. And the initial height in this case is 40 centimeters. Oh, wait a minute. No, it's not. The initial height is the midline. Sorry. The midline, okay, that's right. The midline is equal to high plus low all divided by 2. So that's going to be 1.05. Right? 0.3 plus 1.8 is 2.1. 2.1 divided by 2 is 1.05. Okay, and then the period. So going from high to low is half a period. So... Oh, wait. Okay, now I'm messing up times and distances. Sorry. I'm thinking too quick. Okay, high minus low is 0.6 minus 0.4 over 2. That's equal to 0.1. Okay. I was getting the times. I was mixing up the times. Okay. This is 0.6 plus 0.4 over 2. That's equal to 0.5. Okay, good. Time. So, period over 2 is to the high to the low. And that's equal to 1.5 seconds. So the period is equal to 3 seconds. So now your equation is h is equal to 0.1 sine, we're going to say 2 pi over 3t plus 0.5. Yeah. Let's make sure that makes sense, though. I think there might be a phase shift somewhere, actually. Yeah, okay, and then we have to do a phase shift. Okay. But then this is like plus some phase shift. Okay. And what we need is we need for everything, in order for this to be at the maximum, everything inside of here has to be equal to pi over 2 when t equals 0.3. Right? Because the maximum height happens at 0.3 per second. So I'm going to say 2 pi t over 3 plus phi equals pi over 2. And then this happens when t... Oh. That's it. Okay, I got to go teach actually real quick here. Unfortunately. 3 over 10, that goes away. So pi over 5 plus phi equals pi over 2. So phi is equal to 5 pi over 10 minus 2 pi over 10. So that's equal to 3 pi over 10. Okay, cool. All right, there we go. So your final equation, h is equal to 0.1 sine of 2 pi over 3t plus 3 pi over 10 plus 0.5. That's the equation. Yes, and that's what this is. So then you just plug this in for this. And then you just plug in t equals 0. Yeah, right? Does that make sense for the rest of these ones here, Jarhi? Once you get to this, I think you're done. Then you just plug in things. Yeah. Here, I'll save this for you so you can see it. What was this? Your name was Happy something, right? Happy Face. Okay, cool. Nice. All right. I got to roll out pretty soon here, so let's end the stream. All right. Thank you, everyone, for coming to Actual Education Office Hours. Appreciate you guys all finding us on Twitch and YouTube and TikTok. All the things today. Our next stream is going to be tomorrow. That's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. If you ever want to know, oh yeah, yeah, I tagged you. It's in the chat. Happy Face. Always let me smash you. Yeah, I appreciate you guys as well. Okay, so with concluding that, what we're gonna do now is we're gonna go raid somebody, and then I'm gonna go teach vector calc to somebody else. So yeah, make sure to go. Like if you want to get more math help, go follow all our math streamer friends. That's all their Twitches. And then if you want to figure out when they are streaming, there's a command for the calendar. Okay. All right, let's go see
Maybe.
who we go. Let's go see who we're gonna go stream. Let's go stream manager. Change this. I'm gonna go raid somebody.
Phone's at 7%. I gotta go.
All right, you good? Good to see you, dude.
Peace.
All right. Good to see you, dude. Peace. We're gonna go raid. Globus is doing internet things. Microscope Monday. Let's go say Globus. Globus is cool. Yeah, go say hi to Globus. Looks like he's doing some weird. I don't know. Something with manifolds. The wizard. Okay. All right. Go say hi. Enjoy the start of your week. Thanks for coming by. We will see you guys tomorrow. Peace.
Parameter and apply the step which moves the point. This is the back